Okay, looks like we are live. Looks like let's make sure everything's up and running, as we do every week. And yeah, it looks like we're good there, and we're good here. Good. Alrighty then. So, welcome to the live chat. A little tired today. And Susan, I think you would agree you're a little tired today. Yep, yep. I've gotten that from several people already. Geez, Steve, I feel tired today. What's going on? And I personally think it's because our bodies are completely confused with the fact that we have all this sunshine. The sun's just starting to set now, and it is 36 degrees in the Poconos, 48 degrees and windy down here in central New Jersey. It feels like winter, and we had flurries up by the Catskills and Poconos. You had snow showers in western New York. So, yeah, a little bit of seasonal confusion, I think, is going on here with the weather. And as a result, I think that's why it's impacting a lot of people around here. Um, it certainly is something that kind of drains the energy out of you, especially when it's sunny out, you're ready to go outside and get the day started, and then the chilly air just hits you hard. So let's take a look at 150 millibars, okay? And you can see a nice core of polar air. 850 millibars is getting ready to swing through our region. Impressive cold air transport. In January, this would be impressive. So as we are in April and we're looking forward to baseball games and going outside and nice walks in the park, no, you're bundling up, and in some cases you're concerned about frost and freeze concerns with your plants. So yeah, this type of, let's say, seasonal confusion of your body could definitely lead to you being a little bit tired, more tired than what you would expect. So I think that's yeah, the weather does stink absolutely, or yeah, that's the right word there, Susan. Exhausting. It's exhausting. As a meteorologist, it's exhausting because you just wanted to get warmer so you could enjoy it. And to be quite frank, warm weather or non-severe weather in the spring and summer is essentially our days off because you really don't get that much in the winter because you're always busy because you got clients to take care of from a variety of reasons, from dealing with ice, black ice, snowfall, dealing with whether or not a storm's going to be an issue 7 days out, stuff like that. Once you get into the spring and summer, you're supposed to kind of back off until you get to the hurricane season. Then you pick up again. But you're supposed to have a little break. Not this year. This year we're having snow flurries. Ironically, we could buy a snowflake in January and parts of February. So, gotta love the weather. It's always going to keep you on your toes. So, what I want to do tonight is explain what's going on with our weather pattern and explain what's setting up. I also have some questions that were sent to me via email that I want to read and I'll answer. But it basically falls under, and I'll read it now, it falls under what we're going to be talking about tonight. So the first question, it's a three-part question. We had an east-based La Nina, then you mentioned briefly west-based, true, but now I'm seeing anomalies have shifted and it looks more east-based again, but we're considering this now as a basin-wide La Nina. I'll explain that in a minute. Last year, you kept hammering home the impact of La Nina in a negative PDO state. I can't remember the exact chat, but you explained that in a negative PDO, typically La Ninas are more east based, and that the pattern gets weird, in quotation marks, when it's a negative PDO along with a basin wide west based La Nina. We'll talk about all of that. What does the overall summer pattern typically look like? We'll definitely cover that. And we'll talk about the sea surface temperatures in the Atlantic. And I talked about this morning in the premium long range discussion and in the video. So premium member, definitely dive on that in terms of all the technical lingo. Is there a bigger sea surface temperature climatological reason why we are seeing a third La Nina? I have some theories, but I am far from proving it. But I'm just going to give you some thoughts off the top of my head of what I think we're seeing. Aside from the 800-pound elephant in the room, AGW, is there a reason why we've had a persistent La Nina, but global temperatures haven't gone down much? They dropped like a hammer from 2010 to 2012 during the double Nina, but not so much now. Do orientation and overall strength of the Enzo event play into that? Okay, so that's a lot of questions there, which we're definitely going to be getting into. And then we'll go and go back to your questions at the premium chat, and then we'll check out the YouTube chat, which looks pretty good. When did you get modernized? Oh, yeah. Monetized. I cannot say that word. And by the way, I am learning Spanish, so now I'm going to butcher 2 languages for the price of 1, which is going to be outstanding. Look, I made my English teacher retire in high school. That's how bad of a speller I was. Thank God for spell check, or else I'd really be in trouble. So now I am doing what am I using now? Rosetta Stone, which might actually burst into flames by the time I'm done with it. So we'll see. Oh yeah, so yes, I have been. YouTube has granted me the lovely ability to monetize, right? Monetize my feed, which means I apparently have pushed into the semi big time on YouTube. I don't know, but I'm like, all right, whatever, that works, So good times there. So first, let's talk about our sea surface temperature anomalies here. We have a La Nina, clearly. Okay. Question is it east-based or is it basin-wide? During this time of year, use extreme caution when dealing with Nino 1+2. I kind of take this out of consideration because it's such a widely fluctuating feature, okay? If you're going to base your La Nina characteristics on this feature, be warned that 1 week it could be -2 degrees Celsius, and then next week it could be neutral. So it doesn't have a sustained influence. It's hard to lock that in. So and it can swing on you in a matter of just a couple of days because of the more shallow nature of the body of water here. As you head out towards 3, 3.4, and 4, that's where your sea surface temperatures are more sustained and you have a deeper subsurface support. And what I'm seeing here, when I combine that with the forcing mechanisms that we're seeing in the SOI, and let's see here. Let me go back here for a second. And I want to pull up. Here we are. And then notice where we're getting a lot of our sinking air focusing here over the Pacific. And take a look at, let's see here. Probably should pull it. Here we are. Perfect. You see this signature right here? This tells me that La Nina's influence on the atmosphere, which is what we're following anyway, is clearly more central based. If this was an east-based La Nina, what you would get is you see this area right here, and here, and here. Well, what would happen is that it would be focused out here, and you'd start getting convection near the date line. That's why east-based La Nina was so interesting as we went to last winter, because it would support the better potential of displacing the ridge around the southeast coast towards the Bahamas. In this case, you have your strongest sinking air, your strongest suppression around the date line, which chokes off your convection. Let's see, which we could see right here. Let's see if we can enlarge it. So again, here's our date line. Not much of a convection. Where's your convection? Well, it's out here, which is supported by your very positive IOD. So the IOD, which is supported, which is basically the Indian Ocean dipole here, when it's very warm and you have a La Nina locked in, what you end up with is a support for convection around the Philippines, which we are seeing clearly starting to take shape, and they kind of feed off each other. So one feature feeds off the other. Let me go back to that. There it is. So there it is. Okay, so these two feed off each other, okay, which leads to a lot of convection here, sinking air here. That sinking air kills off your subtropical jet stream, which is why you get support for an active hurricane season in the Atlantic, because you knock off the shear. Okay, there's nothing to inhibit the development once you get a warm core low to develop. It also signals the support for a ridge out here over the southeast. Why are we having a third La Nina? Okay, here's my theory. I think that the presence of a sustained negative PDO, which is here, is helping to feed into the subsurface and keeping your La Nina sustained. While that's happening, it should not be ignored the fact that our sun is becoming more active. And that is having an impact on our ozone depletion. Now remember, we started off spring with well above normal ozone because we had a major stratospheric warming event. Now all that ozone is getting broken down, and that leads to rapid cooling. So that leads to this environmental state. All right, we start off well above, and now we're trending to well below. And we're getting these little warm pockets here in the mid-levels, warm pockets and cold pockets. So these are all interacting. And that interaction in the atmosphere is helping to sustain a La Nina circulation rather than letting it naturally collapse. So it is my theory, which I'm still working on actually proving, but I'm just telling you what my thought process is and what I'm seeing. If I can pull back. Here it is. Okay, let me go back to this area and pull up. Where did I put my subsurface here? Here we are. I think what's happening is this here at the subsurface is being fueled by this transport of our negative PDO. So the cold water is pulling up in the Gulf of Alaska, transported down the west coast, and is enhancing as it's sinking because its salinity is greater, is enhancing the cold pool below the surface of our La Nina. Now, the tricky part is trying to find a way to prove that the same situation with the solar components and with the PDO state happened in the 50s and 70s. Thus far, I don't have enough data to prove that. But it's a theory that I have. And thus far, based on what I'm looking at, I was kind of advertising kind of like a midway point, not the worst case scenario, so to speak, full on support and full on influence. But it looks like we're definitely moving in that direction. And the fact that our SOI numbers are steadily rising tells me we're looking at a moderate La Nina. Now, when you combine three factors together, well, really four factors together, for the spring and the summer, and you could probably push this to the fall, you end up with an interesting dynamic here. Because remember, it's not just La Nina, it's not just the PDO, it's not just the AMO, which is the Atlantic sea surface temperature anomalies. And it's not just what's going on in the Indian Ocean. They all interact together. Combined with what's going on in the stratosphere and the active solar state, you end up with an interesting interaction between these features. So there is a great deal of volatility, a great deal of chaos involved here. So what I'm going to tell you is the best I can make out of what is evolving here, but my confidence is low. So I want you to understand that. So here's what I think is happening. Our La Nina is being fed back, or it's in a feedback loop, because of the combination of what is happening in the Indian Ocean and what is happening in the Northern Pacific. So the Indian Ocean is enhancing the circulation, keeping our La Nina locked in. The negative PDO is feeding the subsurface, allowing for intensification of our La Nina state after a bit of weakening earlier on. And that is supporting a basin-wide La Nina combined with a negative PDO state. What does that mean for the United States? Well, first of all, get ready for a lot of news reports about how California doesn't have any water anymore. They're going into a major drought. And I'm not talking about, it's a dry season. I mean historic major drought. Understand, if you ever take college-based meteorology classes, and you take, let's say, Climo 101, you're going to learn about a major drought that happened in the West from about 1100 to about 1250. This drought literally wiped out an entire civilization that was living right around the desert Southwest. Wiped them out. No more water, no more ways of growing. They either left or they died. This is why you do not build major cities in drought areas like this, like Los Angeles or Las Vegas, okay? Because you may have your golf playing field for a short time, but in the long run, you end up with these major droughts. So that signal is supported by what we're seeing here. We know, based on the records of basically tree rings, right? We know what type of weather patterns were supported by this environment. And we know, based on the study of rocks and soil and fossilized animals' remains, of the type of water environment. All right, so colder water, more density, more salt. So you match up with the negative PDO environment. So that leads to a nice ridge over the desert Southwest and West Coast. A little bit more active weather around the Pacific Northwest, but watch out for your major heat wave out of this pattern again. Significant severe weather in the plains. We've talked about this. We've already seen it. We ain't seen anything yet. We're going to see more because you're going to get a nice robust ridge over the southeast transporting tropical air from the Gulf of Mexico right into the Mississippi River Valley and towards the Ohio River Valley. And eventually we'll get towards our neck of the woods. But there's a catch. That's where we go to the Atlantic. The Atlantic is going through what we call a negative AMO state. Now, there are some scientists who they doubt whether we're actually in a negative AMO, and they're suggesting that the Gulf Stream is collapsing. They're oh look, the Gulf Stream's right here. There's no sign of it collapsing. But if you use model data and you melt all the ice over Greenland, the theory is that the AMOC, the Gulf Stream, would basically collapse, which would lead to rapid cooling over North America and Europe, and because you no longer have the heat transport anymore. I don't think that's happening. I think what we're seeing here is what we saw in the 50s and 70s, which was a negative AMO state. So what this negative AMO state does is that it limits the heat content of the Atlantic Ocean from Africa, let's say about Cape Verde Islands, to about the Eastern Caribbean. So you're less likely to see Cape Verde long track hurricanes in this type of environment. But, much like last year, you can get tropical activity really kicking up a notch around the Bahamas, the Caribbean. Notice you had a lot of tropical systems last year really get their act together once they got to about Jamaica and on eastward or on westward. Notice that. So the Western Caribbean is a concern for significant tropical activity. The Gulf of Mexico, watch out, Texas, Louisiana, Mississippi coast, and the Bahamas, watch out for the East Coast. This type of environment leads to below normal heights around the Aleutians, which we've seen, which led to our backdoor cold fronts. That plays off of what's happening here with our ridge complex. And what you get here is a clash of air masses over the North New England and the northern mid-Atlantic. I think we're going to see a summer where I would not be surprised if you get Philadelphia pushing in the 90s and New York City struggling in the 70s. It's going to be that kind of crazy summer. And I'm very concerned about rapid flips in our precipitation values from well below to well above and leading to significant flash flooding and damage to topsoil, because then you're going to more likely wash away your topsoil in those environments. Not to mention the fact our infrastructure just is god awful, so that's going to be a concern as well. So that's how I think that all these factors are interacting in terms of the sea surface temperatures. And then you have a more active sun, which enhances the cold stratospheric environment. And what that's going to support is enhancement of instability in the atmosphere. So when you're looking at thunderstorms and you're taking a look at the infrared satellite picture, remember we talked about the colder the cloud top, the stronger the lifting? Well, the more unstable the atmosphere is, because you have a very cold environment in the upper troposphere and lower stratosphere, the more likely you end up with dynamic thunderstorms and also the potential for rapid intensification of tropical low pressure systems. Do not be surprised this year, and I'll detail this more when I put out the tropical update in May, that we see once tropical systems get towards the mid-latitudes, say Florida on northward, that you see rapid intensification of these storms because of the mid-level, cold, unstable environment. Just something to put in the back of your head. Would not be surprised to see that. So that's how I'm seeing this pattern all kind of interact. I've been getting the same type of question left and right about this. It leads to cool springs that rapidly flip to very warm springs without much notice. So just kind of put that. You're on notice for May. Do not be surprised if 1 week we're in the 50s and the next week we're in the upper 80s to lower 90s. And you have no chance to adjust to it. You're wearing sweatshirts 1 week, and then the next week you're dying in shorts. So just be prepared for that, because I definitely see that being a threat. And so you end up with this pattern where for the spring, we're going to continue to deal with these pesky upper level lows. And as long as you have them in this scenario, in this area right here, you're going to be dealing with a clash of maritime air masses and polar air masses. And ahead of that development, the transport of tropical air masses trying to push northward. Volatile weather pattern continuing. We get a bit of a break through the weekend. So if you're going to baseball games and whatnot, should be absolutely beautiful out. A little chilly, but not bad. And then we go back into our wet weather pattern once again for next week, which could lead to storms supporting about half an inch to an inch of rain. Not mind-boggling flooding or anything, but still active nonetheless. So that's where I'm seeing everything kind of play out here. I don't see anything that's going to change the support for the development of upper level lows based on the stratospheric environment and the way that La Nina enhances the polar jet stream in the first place. Notice here, let me pull up the winds here, the forecasted winds. And we'll do the observation here. Okay, your strongest winds are all associated with your polar jet stream. Your subtropical jet stream, which is down here, note how weak it is. In La Nina states, the fact that this feature is weak means that when you get a warm core low pressure system, it can't shear it apart. It's too weak. The circulation associated with a tropical storm / hurricane can overcome this type of environment. So that when we talk about the influences of La Nina, basically what you're talking about is the organization and structure of your jet streams. Your polar jet stream is stronger, your subtropical jet stream is weaker. And so your polar jet stream tends to be more volatile, and you have more of a north-south orientation, a lot more wavy, a better potential for upper level lows to cut off, and your subtropical jet stream is basically flat, all intents and purposes. Okay, so I'm going to go and start answering your questions and see what we got. We got plenty of questions here in the premium chat that we're going to be going over. And I see YouTube chat is looking pretty good too, so we'll definitely hit on that. And then we'll see where we're at from there. Okay, let's see here. All right, the only thing missing is a 700-foot tall ice wall. That's called the Eastern Great Lakes and Oswego, especially around the Tug Hill Plateau. Snow Boss says this weather stinks, and yeah, I can totally understand that. As a baseball fan, this weather stinks. Of course, my baseball team's kicking butt and taking names, which is great. Unlike today, they lost today, but that's okay. But yeah, this weather is not good at all for outdoor activities, I would agree. Also, a report of had a quick sleet here in the Lehigh Valley this afternoon. Yeah, that's all because of the impressive cold air that's been in place over the Eastern Great Lakes and swinging towards eastern Pennsylvania. Impressive cold air transport. Even for this time of year, I mean, even for if this was January, it would be impressive cold air transport. Where was this weather when I needed it in the winter? Isn't that true? I mean, think about this here. Understand this. All right. What's happening now in the atmosphere, understand we're dealing with different wavelengths and different influences. If this cold stratospheric environment was happening in the winter, you would see none of this. what you would see is a mild weather pattern, ironically. So it's almost like a flip because of the way that the 500 millibar jet stream is evolving and what's influencing those that evolution. Is this kind of weather pattern with a basin-wide La Nina, negative AMO, and negative PDO something that could feed back on itself and keep these type of conditions going into the next fall and winter? There's a chance. Here's the thing: in terms of our changing climate and the feedback loop and the activity of the sun, we're kind of going into new territory here. The triple La Nina evolution, and this is part of the question about why aren't we seeing the temperatures drop? The fact, let me pull this up, the fact that we have well above normal temperatures all over the Indian Ocean and over the Northern Pacific is counteracting the influences of La Nina. So, as a result, you're not seeing the cooling effect that you were seeing in the 2010s and 2012s. The question now is, does this environment feed back on itself and force a La Nina that continues for a fourth wave that would get you into the winter? I don't know. I've never seen anything like that. Climatology, history would tell you no. But we're dealing with a completely new ball game and completely different rules. So I don't have confidence in that right now. It's certainly something to consider. Remember when I questioned if we could have a third La Nina winter, and you said very rare, but it looks like a possibility. What would that mean for a third La Nina winter? What type of winter would that look like historically? If it remains basin wide and moderate, then it's a warm winter. But I don't know that. I don't know whether or not that La Nina is going to be collapsing. I don't know whether the PDO remains negative for that entire time period. The first signal could be cooling in the Indian Ocean, which kills off the feedback loop, which then leads to a weakening La Nina. But to be honest with you, you could always take model data and go with that, but I have no confidence in that. And the reason why is because model data and machine learning is based off of learning from previous events. But if you don't have the same forcing parameters that you had in those previous events, and your atmospheric state is even slightly different, I mean, just slightly different. For example, a change in your precipitable water values globally, then it becomes that much more difficult to trust that output. So then your confidence of that solution has to decrease. And it is my job as a meteorologist to warn you that confidence would be low in that type of forecast. The Western mega drought from 1100 to 1250 had a negative AMO as well, didn't it? Actually, we don't know. There's conflicting data on that, and the reason why is because the amount of data that we've been able to collect for that time period, for some reason, has been very difficult to collect. There are some theories that it was, but there's conflicting data because of rainfall amounts that were collected that would argue for a positive AMO during that period rather than a negative AMO. So it could have been a time period where it was just in flux and changing, which could certainly happen. And this time we're unlucky enough to have all three phases in a negative state. Do you see that there was a surprise geometric storm today due to an unexpected crack in the Earth's magnetic field? I heard about it, but I haven't read about it. So I'm kind of commenting on it too much because I don't have a lot of background or a lot of details on that. Okay, now let's see what we got on YouTube. Can you talk to Mother Nature and tell her to get her act together? Mother Nature doesn't listen to me, and it's never a good idea to tell Mother Nature what to do, because then you end up with a tornado in your backyard. Since when did you get? Oh, okay, yeah, I already read that. How long do La Ninas usually last? Usually, that's a great question. Usually, they last about 9 months. It's rare to get double. It's even more rare to get triple. Okay, getting a triple La Nina event is like winning the Mega Millions, but in a negative way if you're a fisherman in the Pacific. So yeah, it can happen, but it's very difficult. Let's see here. Is it normal for it to be this cold at the end of April? Okay. The year I graduated college, as you know, I went to SUNY Oswego, which is just north of Syracuse. It actually snowed that morning, which freaked out my parents. So it can happen, especially in northwestern New York and higher elevations. You could definitely have a chilly April. In fact, when I was 18, what was it, 18 or 17? No, I think, no, I'm sorry. I think it was 17. The Yankees were playing at home in April, and the game got snowed out. It wasn't like opening day. It was like the second or third week in, and they got snowed out. So it's not something that's impossible. It's annoying, that's for sure. Let's see here. Will this lead to a milder winter, and will they enhance the number of hurricanes we get this year? La Nina will definitely enhance the number of hurricanes we get this year. Does that mean that they'll impact us? Not necessarily. There's a lot of factors that go involved in that. When it comes to hurricane tracks, what you want to do is take a look at the overall 500 millibar pattern or the upper level winds that we were just looking at and see how they are aligning with the approaching tropical system. Sometimes what happens is that the pattern sets up to act almost like a goalie attendant, knocking any tropical system away from the East Coast. You get a lot of tropical systems, but they don't remain as active. Or should I say, they don't reach the East Coast. They remain active, but they just don't reach the East Coast. As far as whether it'll lead to a mild winter, again, that will depend on how the pattern is evolving as we move through fall. I'll have a better handle on that as we get beyond the summer into the fall months. Will this lead to more rain over the summer? Yeah, that's a great question. I would say it leads to more unsettled weather conditions for the Northeast. And I'm pausing here because this summer is going to feature a lot of interactions of three air masses. The maritime air mass you're going to hear a lot about from the northwestern Atlantic. We already have this spring. The other air mass you're going to hear about is polar air masses. They're usually the last air mass to come in. And then your third air mass is going to be your tropical air mass. Now, if you get your tropical and your maritime air mass to interact, which would probably be in the form of a stalled warm front, that's going to lead to cloudy, showery conditions north and east of those frontal boundaries. But if it pushes to the north of you and you're south of that boundary, it's going to end up being beautiful. Temperatures in the 80s, high levels of humidity, maybe an isolated thunderstorm, but most of the day summer-like. So where that boundary sets up, that could also end up in New England, and most of the northern Mid-Atlantic ends up with a period of dry weather, although humid. and then the polar air mass comes in with a major rainfall event. Now, if you end up with a situation where those air masses are clashing right over the northern mid-Atlantic, and then you get the cold front coming in from the west, that could lead to a lot of rain. Throw in a tropical influence, let's say a remnant tropical low, you're talking about a 3 to 5 inch rain event. So you can see where all these mechanisms can come together to create one heck of a mess here. What I'm trying to explain to you is that what I'm seeing here in the observations opens up a lot of potential features that can interact in a negative way over our neck of the woods. And it could lead to a very memorable summer for our region, depending on how these features interact. And of course, Dylan has asked once again. Dylan loves severe weather. I have noticed your username and on YouTube chat. You love severe weather. I get it. Here's what I would suggest to you. If you are in southeastern Pennsylvania or southwestern New Jersey, you have a much better chance of seeing severe thunderstorms than anywhere else. So if you really want to experience them, I don't know what your age is, but if you're under 18, definitely reach out to your parents. But if you want to see severe weather around this region, that's where you want to go. Of course, sometimes central New Jersey can pull out a wind as well. Let's see here. Remember, snow in the Poconos on Mother's Day one year. Yep, that is true. So a lot of great questions here tonight, guys. Lots of great questions. Memorable in what ways? Are you talking about tropical direct impacts or more on the severe derecho version? Yes, both. Okay, so I suppose I should give a little bit better explanation of what I'm talking about here. It'd probably be helpful. Let me see. Yeah, this would be perfect for illustration purposes. Okay. So let me walk you through this. I am not saying, or nor am I confident in, that we will see all these features that I'm about to talk about. But I'm confident in that we'll have the potential to see all these features, depending on how all these upper level and sea surface temperature anomalies interact. So in our neck of the woods, we're going to have roughly 3 features that we're going to keep an eye on. The first feature would be kind of like this trough and upper level low type scenario over the Canadian Maritimes. The second feature will be a ridge that's going to be taking shape that's just starting to form here from to the north of the Caribbean through the Bahamas and into the Gulf of Mexico. This is going to be your Western Atlantic ridge, and how this flexes in relation to this trough is going to be a major story for this summer, because this feature and this feature will feed back on themselves and strengthen each other. And how that interaction plays out, because remember, you have to have a conservation of mass and energy. Okay, this is basic physics stuff. Okay, we're going to go back to high school right now. The atmosphere is always looking for a equilibrium, even though it never really reaches it. It's always attempting to. So you're always looking for a balance between mass and energy in the atmosphere. And that balance sets up an interaction between this ridge that's starting to develop and these troughs that are starting to develop. And the interaction between those two will transport tropical air northward and maritime air southward. And how they clash and interact over the northern mid-Atlantic will set up your potential for instability in the atmosphere and for thunderstorm complexes, but also can support the ability for tropical systems to intensify and either move up the East Coast or remnant lows with a lot of moisture swinging through the Tennessee River Valley and heading up towards our neck of the woods, running into that maritime air mass and leading to a heavy rainfall event. The third feature will be these troughs and upper level lows in the Aleutians and the Gulf of Alaska, that instigates troughs here that will support cold fronts at the surface to run in and interact with the other air mass interaction here, which can lead to major severe weather outbreaks and also help to transport that remnant tropical low from the southeast into the mid-Atlantic with three air masses interacting and lifting precipitable water values over 2 inches, which can lead to significant rainfall events. There's also a threat where you could get an upper level low, get cut off here in the Tennessee River Valley, interacting with our ridge, interacting with our trough, leading to a block here at the surface of high pressure and forcing a storm up the East Coast. Those are all the potential factors I'm seeing. I'm not saying that they will definitely happen. I'm just saying that based on everything I'm seeing here, the potential is there that we need to watch. Let's see here. What would you say about this year's Atlantic hurricane season, very active on AMO cycle? The AMO cycle doesn't impede the development of tropical systems in terms of frequency. There is no difference in frequency in the AMO. What there's a difference is the rapid intensification in the Cape Verde hurricanes, which are out here. Okay, so with a positive AMO, you get these tropical systems able to rapidly develop out here because you have very warm waters. And that means that you get these hurricanes that are able to constantly intensify all the way until they get to North America. In a negative AMO, your tropical waves are kind of hindered. So you don't see that intensification until you get past the Greater Antilles, or should I say the Lesser Antilles, and get to the south of, let's say, Hispaniola and Jamaica. And you also see a lot more interaction around the Bahamas. Frequency of storms are dictated more, in my opinion, by the state of your El Nino or La Nina events, how strong they are, and how much influence they have in reducing shear. Another factor beyond the atmosphere is also now our inclusion of subtropical systems, whereas if you had included them in the 50s and in the 70s as named storms, you'd have a lot more named storms. So there is that factor as well to consider. And we're also seeing more subtropical and tropical systems because our ability to observe them are better. But that doesn't negate what we're seeing in the atmosphere. Let's see here. The last threat is the one I am most concerned with. A basin-wide La Nina and a negative PDO with a trough in the central U.S. and a negative NAO block. Yikes. Yeah, I mean, the potential there is to have all of those features all together, throw in a tropical system, and you got a headache on your plate here. And what concerns me here is that when you consider the impacts of precipitable water values on our rain systems in the fall, in the summer and early fall, it's a major concern for flooding, and one which I don't think people are going to be prepared for. Any indication as to whether there will be a lot of Sahara dust being blown west this year? Thus far, let me see if I got that data updated yet. I've been keeping an eye on it, but I haven't seen anything all that impressive yet. There we go. So you have your traditional amount. This isn't all that unusual to see. Once we get towards June and July, we'll be able to study this more and more frequently. And I think we'll get a better idea of that potential. I consider the Sahara dust influence much like the MJO. You kind of take it 2 weeks at a time, and you don't look at it as a season-wide influence. More of a short to medium term inhibiting factor to keep an eye on. Okay, we got 9 more minutes left, and then we will be shutting it down. So definitely get your questions in. Great questions tonight, guys. Absolutely outstanding questions. So definitely keep them coming. I'm really, really impressed with what you guys have been asking. As always, you make this chat easy with these questions. So thank you. Let's see if we have anything out of the ordinary in the current weather pattern. You can see for this weekend, if you have plans for this weekend, it'd be a little cool, but plenty of sunshine, so that's certainly good news. Next week, we're going to have this interaction once again between maritime air masses. There's our high pressure system. Maritime air masses getting filtered in. Pacific and tropical air masses trying to push northward at the same time. So Monday we'll see showers as a result. You're basically going to get this frontal boundary hanging around with these waves of low pressure for much of next week until we get to maybe Thursday evening into Friday. So if you have plans to do things early next week, you might want to have some backup plans. How about those Mets? I don't want to jinx it. They've been outstanding, but I don't want to jinx it. Let me get to June before I trust what I'm seeing. How many heat waves this year? That's a tough question. I think it kind of depends where you're living. I think New York City Metro, I definitely think we'll probably see 1. Connecticut, you might miss out, which probably is a good thing, because of the maritime influence that we've been talking about. Same thing with the East End of Long Island. I would say there's a much greater potential for multiple heat waves in the Philadelphia Metro, points south, than central New Jersey and points north and east, because of where our boundaries are going to set up between maritime air masses and tropical air masses trying to push northward. But it's going to be interesting to see how that plays out as we go forward. So, okay, good. All right, I think we've gotten our questions in for tonight. I think that for tonight, I think we'll be calling it a night as a result. Thank you, as always, for joining. I really appreciate it. Again, you make this chat easy. And we'll see how all of these factors play out. We'll keep an eye on La Nina, and definitely send those questions in via email. I'll be happy to answer them like tonight, and we'll go from there. So have a wonderful night, and have a wonderful weekend on the way. And as always, stay safe out there.